but I'm going to do my best. All right, let's start with our first um, series of talks. This is called The Heat is On because it's the heat that's really driving the whole system. We would not have hurricanes, we would not have excessive precipitation, we wouldn't have a lot of the issues we had if it wasn't for the change in the heating that we're getting. So the title of the first one is The Heat is On, and it's really driving our hurricanes and storm surges, our extreme precipitation, and really our droughts as well. And these extreme events are happening one after another, and sort of one thing and then the other, then one thing and then the other. It's just amazing what's going on. Sea level rise are harmful algae blooms, which, by the way, we have a big one coming onto the coast right now. And of course, today's topic, climate and human health. And we have one more in our big five, and that's biodiversity, and that'll be next year. So that'll be the topic of our fifth Florida Climate Conference next year. So I want to show you this. We worked on this graph for 2 years, trying to figure out how to tell the story in one picture. And so the ice age was 24,000 years ago, the last ice age that we had. And the one that David talked about during the Roman Empire is hardly even a little bump on here compared to the scale of this graphic. So 24,000 years ago is when we started coming out of the last ice age. And you'll see that it took 12,000 years for it to get up to the bottom of that green zone. And that's about a warming of 3 degrees. It took 12,000 years. So remember that number. At that time, there were only 5 million people on the Earth, 5 million. Then the climate went through this long period, as far as we're concerned, of stability where it didn't vary more than a degree. And that stayed until 1950. During that time, our population went from 5 million to 5 billion. And because we had this incredible climate stability, but in 1950, it went out of the green zone, through the yellow zone, and into the orange zone, and we're heading for the red zone. The amount of temperature rise that we had in 12,000 years, we just had in 170. So when people say, well, the climate always changes, I don't even like the word climate change. I'm not the only one, I guess. But I like the word climate warming because it's getting hot. And at the rate we're going now, we're putting ourselves in incredible danger. And what you're seeing outside your window these days is weather that has changed because the climate has already changed. So it's going to continue to change, and that means that our only real solution for the next lifetime is adaptation. And that's why we have the Climate Adaptation Center. That's why I wanted to do this. Because our focus, well, it needs to be net zero and stopping climate warming, coal. It's going to take a lifetime to do that, even if we do really, really well. And in the meantime, we have to get over the bridge to a future stable climate because we're not in one right now. So these are the temperature records. If you look at back to the beginning of the Industrial Revolution, and you can see how at the beginning it was cool and then it started taking off, and it's a ramp, folks. It's growing very fast. And 2023 was the warmest year in human history. We know this from the ice cores and the tree rings and the sediments. In the human experience, we've never had a temperature like we had in 2023. And we have about 6 weeks to go. There's a 95% chance now. So Time to bring your umbrella, Elizabeth. Your two umbrellas. There's a 95% chance that it will be the warmest year in human history. And they're coming one after another. We've had 50 more extreme global heat days around the globe this year than we had in 2000. The last 12 months are 3 degrees Fahrenheit warmer than the baseline during the Industrial Revolution. So we definitely, the heat is on, and that's what's driving things. It's the climate impacts. We know that the chances that this is a natural progression of climate is only 5%. It's a 20-to-1 bet that this is human-induced. Give me that bet every day. I'll make that bet every day and win 19 out of 20 times. That's a pretty good bet. So last year, 500 billion hours of labor around the world was lost due to heat, excessive heat. So that's getting to be a big economic number too. And zooming in, right here in our neighborhood, you know, the last few years, we've had some amazing hurricanes. Hurricane Ian in 2022 did $113 billion of damage and drowned a lot of people, most of them right here in Florida. We had an 18-foot storm surge. That's salt water. And then Hurricane Idalia, we had 4 to 5 feet of storm surge with a storm that was 150 miles off the coast, never came inland. These storms in the past did no flooding, did nothing. And yet we had a record storm surge from a storm that was a hurricane, but it wasn't here. And it was to then the worst flooding we had seen here. And then last December, out of the clear blue sky came a cold front. Wasn't a tropical storm. And we had a storm surge and surprise flooding again. And then this year, we've had the trifecta, Debbie on the 5th of August with freshwater flooding, Helene on the 26th with storm surge and flooding, and on October 9th, Milton made us ask, is paradise lost? I don't know, remember that book? Anyway, on freshwater issues, we saw a 500-year inland flood in 2022 from Hurricane Ian, 24 inches of rain. We don't get rain like that. Our storm system for removing water is not sized to 24 inches. But yet we had 20 inches this year. So in a couple of years, we've had 2 20-inch plus storms, and the design of our infrastructure is not up to the climate we are now having. We had an unnamed tropical storm on the 11th of June that created a record amount of rain in downtown Sarasota in the history of observations and flooded downtown. Had it been off the coast for 5 more hours, it would have been our first named tropical storm. And we had tropical storm force winds at the airport. But a record rainfall, 10 inches, and 6 inches or so fell in just 1 hour. Can you imagine that? And Debbie was a 100-year flood inland. The whole purpose of this is to show you 500-year floods, 1,000-year floods, 500-year floods, all happening in the space of 2 years. So they're no longer 100-year floods, 500-year floods, 1,000-year floods. What it is what we have now. This is our life. So you saw what Helene did up in Asheville that shocked the world, right? So, I mean, we had a lot of rain here too, but Helene had 50% more rain, according to our attribution science, because warm air can hold more water. So our run-of-the-mill storms now hold 50% more water than they used to, and that's why we're having this excessive precipitation. So, this is what it looks like. This was the bridge to Sanibel after Ian. This is the rainfall map after Ian in that blue area, which goes through Sarasota County, was 24 inches of rain. This is St. Armand Circle after Helene. These pictures aren't really widely shown enough, in my opinion. But the question is, this was the 5th time this year St. Armand Circle has flooded. 5 times in 1 year. If you went back 25 years before this year, not 5 times. So the rapidity of what we're getting is different now. And the question is do we want to keep rebuilding and facing the same result, or do we want to do something different? That's the question we need to answer. Just because we do it some way now does not mean that we have to do it the same way in the future, especially given the information we now have. Now, many of you love Marina Jacks and the Bayfront Park, and this is a picture this summer during one of the storms where our beautiful dolphin base, the statues there, where the dolphins went swimming for the first time since they were put in. And of course, this is the shore downtown in St. Armand Circle. And this is, a scene from June 11th at rush hour. And it's amazing. People drive their cars into this, and I'm thinking to myself, oh my God, what are you doing? On June 11th, we had that storm, unnamed, and you can see that the big impacts are right here in Sarasota. For some reason, we have a bullseye on this, and this is why I call it ground zero for climate warming. Here's another example in Sarasota County, the Laurel Meadows subdivision. Beautiful homes surrounded by water, lots of solar panels. And this is the flooding from Debbie. This is a radar display where we've added up all the rainfall totals, and that area right in there is over 15 inches. But it happens to be over a heavily populated area. So when you look at this, you can see all of the events that are happening and all of these events and when they've occurred, and you can see that most of them are since 2000. These are all of our record events, and we don't have very many record events left that were in the 20th century. They're all in this century. So here's the problem. 95-degree days are going from 10 a year in 2010 to 70 in 2050. 10 to 70. This is a health issue for Sarasota. It's not only going to drive more storms in the future, but it's going to drive increasing sea level rise. We're expecting another 9 inches of sea level rise by 2050. We've had roughly a foot of sea level rise. So we're talking by 2050, in 100 years of time, almost 2 feet of sea level rise in an area where lots of places are 5 feet. Stephanie's house is 4 point something. Most of Longboat Key, all of St. Armand Circle, Minnesota Key, all of the keys. And we're losing these buffers that we had because the sea level is rising and it's almost imperceptible until a storm comes. So major hurricanes average 3 a year, and in our forecast, we said by 2050, it would average 6 a year. Well, we're almost there this year, right? We're at 5, and maybe by next week, we might be 6. So we're hoping not, but it's possible. So this is in Tampa. This is a heat index of 103. In the 1970s, it averaged 10. And in the 2020s, so far, it's already up to 45. It's getting hot quick. This is amazing. Our risky heat days of heat and humidity now have gone up to 54 days since 1970, 540% increase. Warmer summers, 6 degrees warmer than 1970. The average low temperature at night in Sarasota. You wonder why it feels so hot at night, you know? Because it is, right? And so this is a really interesting chart. I know it looks complicated, but it's the temperature of the air versus the humidity. The temperature is on the left column. The humidity is across the top. And you find your temperature and your humidity, and you find the heat index, okay? So when it gets into the red boxes, it's dangerous, okay? And you'll see the red boxes on the right, on the bottom right. There's no numbers in there. And that's because human beings can't survive in that temperature. So there's no numbers. So if the Earth turns out to be in that red zone, we won't be around to measure those temperatures. But we're approaching those temperatures, and I want to show you. Whoop, what did I do? So 106 to 129, you see that white circle? That white circle is where we are right now. And by 2050, we'll be in the green circle. So we're getting to the edge of what we can really do in a lot of these places. So we have to really make sure that our urban development takes this into account and we build cool cities, not hot ones. And so when we build 18-story buildings downtown, because that's the way it was zoned in 2006, and they're one right next to another, we create this heat island effect. And we don't get the sea breeze. Thank God we have that. It's a real asset for this community. But if we block it from coming in downtown, we're going to create, in addition to climate warming, a 5 to 10 degree boost in the heat on a summer afternoon downtown. We don't need to make that choice. We can do something different, and we can still have sustainable development. But if we do that, it won't be sustainable. If we want people to live here all year around, we can't do that. And that's a choice. It doesn't have to be that way. So if we combine the hot summer days and nights, you know, they've gone almost triple. And that's because we get these heat domes. You've heard about this. We get these large high pressure areas, and the heat and the air sinks in the center of these high pressure areas and not moving as fast as they used to, and so it locks the heat in over our areas for longer. So we're seeing longer heat waves. So all of this is having health impacts: heat, disease, air quality, mental health, and part of the mental health issue is migration. And Stephanie told you a little bit about their story. It's a migration story. What do they do? It's not just putting their house back together, but where do they want it to be? Knowing what they know now, what will they decide? And there are hundreds, if not thousands of people right now who are making these decisions. And that's the reason we're having this conference. Because informing these decisions now will help us all make better decisions every single day. It's not about the future, it's about today. It's not about somebody else's life, it's about your own. So heat stress is a big deal, and we'll be talking about this throughout the conference, but You know, the human body can only take so much. And we have CAC members here that were on the edge of heat stroke this summer and had heat effects. And I have emails, and one of them is here, but I'm not going to tell you who she is, but she told me. Believe it or not, heat is the deadliest weather phenomena in the United States. It's not floods, it's not hurricanes. It's hard to believe, but it's heat. And one of our issues with heat is we don't know how to measure heat deaths, okay? Heat deaths occur on death certificates a year later, and then we compile them. So when we have a heat wave, we have no real-time monitoring system to know for sure how many people are having heat stroke, how many people died, how many are having cardiovascular events, how many people are there on certain drugs that are exacerbated by heat that creates medical issues for them. But since this is the largest climate cause of death, shouldn't we have a real-time monitoring system in our medical community that keeps track of this, just like we do hurricanes? We know every minute when a hurricane is coming. There are planes flying in, reports coming out, all the news media is covering it. But yet when we have a heat wave and thousands of people die, we really don't know until later that that really happened. So here's an example of underreported impacts on heat-related illnesses. One of the things I don't lose sleep over much. You know, I'm a climate scientist. I've been through this for a long time. I've thought about the worst case scenarios, okay? So I sleep pretty good. But this is one that keeps me up at night when there's a hurricane during the summer coming on shore in Sarasota where we know we're going to lose power for a week or two and could be followed by 95-degree days every day with no air conditioning, with no way to leave, 24 million people. We are on the edge of having a catastrophe from heat, and people don't realize it. So adaptation now is going to save a lot of pain and suffering and catastrophe in the future. It's just a matter of time. We've had some hints of this in Texas when Hurricane Beryl went in and they lost their power, and hundreds of people died in a few days there. So we need a more sophisticated health system, one with real-time capabilities, a medical infrastructure with multiple locations for treatments. For example, let's say we do have a heat emergency. We're building schools like nobody's business on the west coast of Florida. Couldn't they be heat trauma centers too? Couldn't they have independent power so they don't lose air conditioning? Couldn't they have parking lots for people to park their cars that live on the Keys when a hurricane hits so they don't flood? How many people in this room lost cars, right? Put your hand up. So cars were lost in these hurricanes because they had nowhere to bring them. If our schools were mobilized as emergency centers for climate issues, which happen mostly in the summertime when the kids aren't in school, we're spending all that money on these schools. Why don't we rearrange the pieces of the puzzle that are on the table and do it differently? Steve Jobs did that with the iPhone, and now we can't live without it. He didn't invent the calendar. He didn't invent email. He didn't invent the telephone. He didn't invent Google Earth. He didn't invent maps or calendars or notes. He just put them all in one place. And then now Apple is the most successful company in the history of the planet. And we have that option every day, and we don't take it. It's the inertia of our previous decisions that's really separating us from success here. And with all of you in the room who are leaders and thought leaders, it's really not up to anybody else to make these decisions. It's up to us. It's not our politicians. I mean, you elect them, right? So, I mean, but they know less than you know. Right now, I can tell you, already you know more than they know. So, we're filling the adaptation gap, and you can see in this chart all the science papers that have been written on climate and extreme weather events and mitigation and adaptation. You see those little green things? That's adaptation. It's growing. But we're going to run out of time before we get that big green bar in there if we don't get going. So adaptation is really very, very important. Okay, so let's rearrange and adapt our healthcare system now and our medical infrastructure in advance of these likely events. This is the important thing, and this is the climate umbrella. We impact the climate, and then the climate impacts us. Thanks very much.